We'll start in about 1 minute. Today we'll start on the last section that we're going to cover this semester, section 11.1. It's on the distance formula and equations of circles. One interesting thing that you'll see is that both the distance formula and the standard equation of a circle are derived by using the Pythagorean theorem. Remember that this Friday is test 4. It will be over the chapter 9 and chapter 11 material that we cover. So let's start with 11.1. Okay, we've seen the Pythagorean theorem a few times this semester, but we'll review it. If you have a right triangle, which means one angle is a 90-degree angle or a right angle. The hypotenuse is the longest side. It's opposite of the 90-degree angle. If the length of the hypotenuse is c units, and if the lengths of the two legs are a units and b units, then the Pythagorean theorem says or states that if you square the length of the hypotenuse, that's equal to the sum of the squares of the lengths of the two legs. Okay, so in the xy plane, if we plot any 2 points in the xy plane, we can find the distance between those 2 points by using the Pythagorean theorem. So we're going to do that in this example. We'll plot the points 1, 2, and 5, 4 in the xy plane. So I'll draw the y-axis and the x-axis. And then we'll plot those 2 points. Okay, the ordered pair 1, 2, and then the ordered pair 5, 4. Okay, this is the ordered pair 1, 2, and this is the ordered pair 5, 4. We want to find the distance between those 2 points. So we can construct a right triangle. First, we'll connect the 2 points with a straight line segment. And then we'll construct a right triangle by connecting a horizontal line segment and a vertical line segment that are extended from those points. So the horizontal line segment, we stop until we're directly below this point. And then the vertical line segment. So in general, if a horizontal line segment intersects with a vertical line segment at a point, they form a right angle or a 90-degree angle. Okay, we can tell by looking what the length of this horizontal side is. So the x-coordinate of this point is 1, and the x-coordinate of this point is 5. and 5 minus 1 is 4. Or you could just count the units, 1, 2, 3, 4. But I want to point out that we can find the length of this horizontal side by subtracting one of the x-coordinates from the other x-coordinate. And you can do it in either order if you use the absolute value symbols. I'll just write the absolute value of 5 minus 1, and we know that that's equal to 4. So the length of the horizontal side is 4 units. And then similarly, along the vertical line segment, we can tell by looking that its length is 2. But I want to point out that you can find that length of the vertical line segment by finding the absolute value of the difference in the y-coordinates. The y-coordinate of this point up here is 4. The y-coordinate of this one is 2. And so the length of that side is the absolute value of 4 minus 2. And we know that that's just 2. Okay, we're trying to find the length of the hypotenuse. The length of the hypotenuse is the distance between those 2 points. So I'm going to label the hypotenuse d for distance. And then we apply the Pythagorean theorem to this right triangle. If we square the length of the hypotenuse, so d to the second, that's equal to the sum of the squares of the lengths of the 2 legs. The horizontal leg is 4 units, so we have d squared equals 4 squared, and then plus the square of the vertical line segment. The vertical line segment is 2 units, so we add 2 squared. Okay, then we'll do the arithmetic. D to the second is equal to 16 plus 4, or 20. And then the distance between those 2 points is the positive square root of 20. And whenever we can simplify square roots, we do so. So we can simplify the square root of 20. The square root of 20 is the square root of 4 times the square root of 5, and the square root of 4 is 2. So the distance is 2 times the square root of 5 units. Okay, so you can find the distance between any 2 points in the xy plane just by applying the Pythagorean theorem to a right triangle that you can construct. But we're going to use the same concept to derive the distance formula. So here we're referring to one of the points having coordinates x1, y1, and another point having coordinates x2, y2. So we'll draw a picture of the xy plane, and our diagram or picture is just to help us a little bit. So I'll label this point x1, y1, and then another point I'll label x2, y2. And we want to find a formula for the distance between x1, y1, and x2, y2. Okay, so we're going to derive that formula by applying the Pythagorean theorem to a right triangle. Okay, so the hypotenuse of the right triangle is the straight line segment that we get by connecting those 2 points. And then we're going to connect a horizontal line segment with a vertical line segment. They'll intersect at this point, and they, of course, form a right angle. Okay, well, the length of this horizontal side is the absolute value of the difference between the x coordinates. So if you wanted to, you could project this point down to the x-axis. The x coordinate of this point is x1. And then if you project this point down to the x-axis, the x coordinate of that point is x2. And so the length of this side is, we'll just write the absolute value of x2 minus x1. And then similarly, for the vertical side of this right triangle, if you project this point onto the y-axis, this point is y1. And then if you project this point onto the y-axis, this point is y2. And so the length of the vertical line segment of that right triangle is just the absolute value of y2 minus y1. Okay, then we'll label the hypotenuse d again because that represents the distance between those 2 points. And then we apply the Pythagorean theorem to this right triangle. So we square the length of the hypotenuse, d squared, and then that's equal to the absolute value of x2 minus x1 squared. But since we're squaring it, we don't need the absolute value symbols anymore, because whenever you square a positive or a negative number, you get a positive number. So we'll just write the quantity in parentheses, x2 minus x1 squared, and then plus the length of this side squared is y2 minus y1 in parentheses squared. And we want to solve for d, so we just use the positive square root. So the distance between those 2 points is the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Okay, so when finding the distance between 2 points in the xy plane, you can use the distance formula, or you can use a right triangle that you can construct. But if you're going to memorize the distance formula, that's fine. Just make sure that you memorize it perfectly. All it takes is one little mistake to throw everything off. Okay, we'll practice using the distance formula. Okay, find the distance between each pair of points and simplify the square roots. Okay, find the distance between the 2 points, 3, 2, and 7, 5. When using the distance formula, it doesn't matter which point you label x1, y1 and x2, y2. You can do them in either order. And so I'm just going to use, first I'm just going to find the difference in the x coordinates. This x coordinate is 7, this x coordinate is 3. So in parentheses, 7 minus 3, and then we square that quantity. And then we're going to add the square of the difference in the y coordinates. The y coordinate at this point is 5. The y coordinate of the other point is 2. So I can write plus the quantity 5 minus 2 squared. Okay, then we just carefully do the arithmetic. So inside the square root, the numbers 7 minus 3 is 4, so we get 4 squared. And then we have plus 5 minus 2 squared. 5 minus 2 is 3, so we have 3 squared. And then 4 squared is 16. 3 squared is 9. And so d is the positive square root of 25. But the positive square root of 25 is just 5. So the distance between those 2 points is 5 units, whatever those units happen to be. Okay, so that's all there is to it. The problems come from doing all of the arithmetic correctly. And so adding and subtracting positive and negative numbers can sometimes value up. So you have to be careful, especially when negative numbers are involved in subtraction. Okay, so let's find the distance between these 2 points. Okay, so the distance is equal to the square root of, okay, so we'll start with the x coordinates. So as I mentioned, it doesn't matter which one you use as x1, y1, and x2, y2. But you might choose those just out of a strategic maneuver. So on this one, I'm going to focus on the x-coordinates. The x-coordinate of this point is 6, and the x-coordinate of this one is -2. So one option is just to write 6 minus -2 quantity squared, and then plus. Now we'll look at the y-coordinates. The y-coordinate of this point is -1, and the y-coordinate of that point is -8. So in parentheses, I'll write -1 minus -8 quantity squared. And then we'll do the arithmetic inside the square root. Okay, so here 6 minus -2 is equivalent to 6 plus 2, so 6 plus 2 squared, and then plus, on this one, -1 minus -8. -1 minus -8 is equivalent to -1 plus 8, and then quantity squared. I'm going into more detail than is necessary, but I just want to make sure that you cover all the bases when doing the arithmetic, especially with negative numbers when they're involved. So inside the square root, 6 plus 2 is 8, so we have 8 squared. And then in the other set of parentheses, -1 plus 8 is 7, so we have 7 squared. And 8 squared is 64. 7 squared is 49. And so we get the distance equals the positive square root of 113. Hey, the square root of 113 cannot be simplified further. Be prepared to use a calculator to get a decimal approximation for a square root. Okay, we'll look at a couple more examples. So use the distance formula to find the distance between these 2 points. So the distance equals the square root of some stuff. So I'll focus on the x-coordinates first. -7 is this x-coordinate, and this one is 4. So I'm going to, in parentheses, write -7 minus 4 quantity squared, and then plus -2 minus 6 in parentheses squared. Okay, -7 minus 4 is -11, so we have -11 squared. And then we're adding that to this other quantity. -2 minus 6 is -8, so we have -8 squared. -11 squared is 121, and -8 squared is 64. And so this simplifies to the square root of 185. So let's see, 5 times 37 is 185. So this square root cannot be simplified any further. Okay, one more example. Find the distance between the points -9, 4 and 5, -3. Okay, so this time, well, first, I always focus on the x coordinates first. So one x coordinate is -9, the other one is 5. So in parentheses, I'm going to write 5 minus -9, and then square that quantity, and then add that to -3 minus 4 in parentheses, quantity squared. And then we do the arithmetic. Okay, so inside the parentheses, 5 minus -9 is the same as 5 plus 9. And 5 plus 9 is 14, so we get 14 squared. And then in the other set, -3 minus 4 is -7, and -7 squared is 40. Whoops, I'll just write -7 squared. Okay, 14 squared is 196. The number -7 squared is 49. And 196 plus 49 is 245. So we have the square root of 245. And let's see. So this can be simplified because 245 is 5 times 49. 49 is a perfect square. So we can simplify this one further. So the square root of 245, you can think of that as the square root of 49 times the square root of 5. And then the square root of 49 is 7. So our final answer is the distance is 7 times the square root of 5. Okay, the distance formula is not that hard to apply, but as I keep saying, you have to be careful with the arithmetic, especially with coordinates that are negative numbers. Okay, now we'll start looking at circles. So this says draw a circle in the xy plane centered at the point 3, 4 with radius 2. And then I'll show you how to find an equation for that circle by using the Pythagorean Theorem. Okay, so first we'll attempt to draw a circle in the xy plane. Okay, the point 3, 4 is the center of the circle. It's not really part of the circle, but it's the point that is equidistant from every other point, or from all of the points on the circle. Okay, if the radius of the circle is 2, then from the center, every point is a distance of 2. So I'm going to pick a couple of, well, I'm going to pick 4 points that are on the circle by moving horizontally and vertically. So from the center, if I move 2 units to the right, then this point, 5, 4, is a point on the circle. And from the center, if I move 2 units to the left, so this time I'm at 1, 4, that's another point on the circle. And then if I move vertically from the center up 2 units, this point is 3, 6. And then from the center, if I move vertically down, I get another point on the circle. So this point is 3, 2. Okay, then I'm going to try to draw a circle by connecting those points. So just pretend like this is a circle. I'm sure you can do better at drawing circles, but anyway. Okay, and then the center, I'll label the center 3, 4, if you can read that. Okay, so this says find an equation for the circle by using the Pythagorean theorem. Well, my picture is kind of small. So what I'm going to do, I'm going to try to draw a bigger circle over here. Slightly bigger. And I'm going to label the center 3, 4. And then I'm going to pick a point on the circle. It doesn't matter where I pick it, but some points are more convenient than others. And since a point on the circle varies, I'm going to label this point with x comma y. So x represents the x coordinate and y represents the y coordinate of any point on the circle. And then I'm going to derive an equation for this particular circle by constructing a right triangle and using the Pythagorean theorem. Okay, so the radius of this circle is given to be 2. So the hypotenuse of that right triangle is length 2. The length of the horizontal side of this right triangle is the absolute value in the difference in the x coordinates. So I'm going to write the absolute value of x minus 3, right? Because 3 is the x coordinate of the center, and x represents the x coordinate of any point that's on the circle. And then similarly for the vertical side of this right triangle, that the length of that vertical side is the absolute value of the difference in the y coordinates of this point and the center. So the y coordinate of this point is y, the y coordinate of the center is 4, so we'll represent the length of the vertical side as the absolute value of y minus 4. Okay, then we're going to apply the Pythagorean theorem to this right triangle. But this time I'm going to put the quantity x minus 3 squared plus the quantity y minus 4 squared on the left-hand side. And then on the right-hand side, I square the hypotenuse, 2 squared. And we'll simplify 2 to the second. So we'll rewrite this as x minus 3 squared plus y minus 4 squared equals 4. So this equation is called the standard equation of the circle. Standard equation of the circle centered at 3, 4 with radius 2. So I'll try to squeeze all of that in here. So this is the standard equation of the circle with center. The center is the ordered pair, 3, 4, and radius 2. But it will be helpful to remember that a standard equation of a circle is just the Pythagorean theorem applied to a right triangle. So you can think of this as, in a right triangle, one of the legs squared plus the other leg squared is equal to the hypotenuse squared. That's the Pythagorean theorem. Okay, so using that idea in a specific example, we're going to derive the standard equation of any circle. So if you have a circle centered at the point HK and the radius is R, well, you can probably just look at what we did before and tell me what that standard equation is going to be, but we'll go ahead and draw a picture of a circle. So this is a circle in the XY plane. The center is the ordered pair HK. And I'll pick any point on the circle, and since a point on the circle can vary, we use variables x, comma, y to represent any point on the circle. And the radius is r, so the distance from the center to any point on the circle is r units. So we're going to construct a right triangle. We'll connect the center to that point. This is going to be the hypotenuse of the right triangle, and the length of that hypotenuse is r. That's the radius of the circle. Then we're going to connect horizontal and vertical line segments to form a right triangle. The length of the horizontal side is the absolute value of x minus h. It's the absolute value of the difference in the x coordinates. The length of the vertical side of that right triangle is the absolute value of y minus k. It's the absolute value of the difference in the y coordinates. Okay, then the standard equation is just the application of the Pythagorean theorem to this right triangle. So if I square the quantity x minus h and add that to the square of the quantity y minus k, that's equal to r squared. This is the standard equation of the circle whose center is HK and whose radius is R. So I'll write that down just to help remember. This is the standard form of the circle centered at HK. With radius R. Hey, if you know the Pythagorean theorem, this shouldn't be too hard to remember. Okay, we'll do some examples where we're given the center and the radius, and all we have to do is write the standard equation of the circle. So any misunderstandings can be You can work out those just by practicing. So this says, given the center and radius, write the standard equation of each circle. Oh, and then it says graph each circle. Dang. Okay, so if the center is the ordered pair 1, 3, and the radius is 2, well, we can just write down the standard equation. So in parentheses, it's x minus the x-coordinate quantity squared plus y, the quantity y minus the y-coordinate of the center squared equals the radius squared. Or x minus 1 quantity squared plus the quantity y minus 3 squared equals 4. But you can write down this equation the first time. You don't have to write 2 squared. You can just write 4. Okay, so we'll sketch a graph of this. So the center is 1, 3. And the radius is 2. So from the center, we can move 2 units to the right. So this point should be 3, 3. If we move 2 units to the left, this point is negative 1, 3. Then from the center, if we move up 2 units, this point is 1, 5. And then from the center, move down 2 units, this point is 1, 1. And then draw the circle, roughly speaking. Okay, let's do the next one. The next one, we have a center of a circle at 4, negative 2, and the radius is 3. So we can write down the standard equation. The x-coordinate is 4, so the quantity x minus 4 squared, and then we add that to the quantity y minus negative 2 squared equals the radius squared. And we want to simplify a little bit more. The x minus 4 squared is already as simplified as we can get it. Y minus negative 2 is the same as y plus 2. So we write y plus 2 quantity squared, and then 3 squared is 9. So this is the standard equation. Okay, 4, negative 2. The radius is 3. So that's a point on the circle. This is a point on the circle. So is this, and so is that. So I just draw a circle through those points. So I guess I should write some of the numbers. Okay. All right, one more example of just writing down the standard equation and then graphing. Okay, so this time the center is the ordered pair 0, 5. and the radius is 4. Okay, so the x-coordinate of the center is 0, so x minus 0's quantity squared, and then plus y minus 5 squared equals the radius squared. X minus 0 is just x, and x squared, it's just x, so we'll just write x squared for that term. This one is already as simplified as it can be, x minus 5 squared, and then 4 squared is 16. Okay, the center, 0, 5, that is a point on the x-axis. Sorry, the y-axis. Okay, so the center is 0, 5. So that's the center. The radius is 4, so this is a point on the circle. The radius is 4. This point right here is on the circle, and then the point 4, 5 is a point on the circle. This point is 4, 5. This point, 0, 9. This one's 0, 1. And then 4 units to the left of the center. This point is negative 4, 5. So then draw a circle. Okay, we'll move on to the next exercise. This will be a little more involved, but you've seen everything that you needed to see this semester in order to do this. You will encounter equations of circles that are not in standard form, and the task will be to write the standard form, and then after writing the standard form, you'll be able to find the center and the radius. Okay, this is an equation of a circle, but it's not in standard form. So what we're going to do, notice there's an x squared term and a plus 12x term. So we're going to rearrange the terms so that the x squared is next to the plus 12x. And then I'm going to leave some space before I write the plus y squared plus 2y. And then I'm going to leave some space before I put the equal sign. And on the right-hand side is negative 12. Okay, if you remember the standard form of a circle, it involves squaring binomials. So remember what happens when you square a binomial? You get a perfect square trinomial. So we're going to create 2 perfect square trinomials, and we've had some practice doing that. So first, look at x squared plus 12x. The coefficient of x squared is 1. So the number to add to x squared plus 12x to get a perfect square trinomial is found by first taking 1/2 of the coefficient of x. So 1/2 of 12. See, 1/2 of 12 is 6. And then square 6. 6 squared is 36. Okay, so we're going to add 36 to both sides of the equation. Whatever you do to one side of the equation, you have to do to the other. Okay, then we're going to complete the square on y squared plus 2y. So this time, take 1/2 of 2. 1/2 of 2 is 1. Square it. 1 squared is 1, so we're going to add 1 to both sides. And then the next equation will be the standard equation. X squared plus 12x plus 36 is the binomial x plus 6 squared. And y squared plus 2y plus 1, that's the binomial y plus 1 squared. And then on the right-hand side, negative 12 plus 36 plus 1, that's 25. So now we can identify the center, and we can also identify the radius. The center of this circle has an x-coordinate of negative 6 and a y-coordinate of negative 1. And the radius is the positive square root of 25, which is 5. Okay, so just remember what you learned about completing the square earlier last week, and then apply that to circles. Okay, the next one is the same sort of thing. This is an equation of a circle, but it's not in standard form. So in the first step, we'll rearrange the terms so that the x squared is followed by the minus 4x, leave space, right, plus y squared minus 6y, leave some space, and then that's equal to 23. And then in the next step, we're going to complete the square twice, once for x squared minus 4x, and a second time for y squared minus 6y. Okay, so on this one, 1/2 of negative 4 is negative 2. Square negative 2, you get positive 4, so we add 4 to both sides. Then complete the square on y squared minus 6y. 1/2 of negative 6 is negative 3. When you square negative 3, you get positive 9, so we add 9 to both sides. Then the next equation is the standard equation. X squared minus 4x plus 4 is x minus 2 quantity squared. And then y squared minus 6y plus 9, this is y minus 3 squared. And then 23 plus 4 plus 9 is 36. So now we know what the center is, and we also know what the radius is. The center is the ordered pair 2 for x and 3 for y, and the radius is the positive square root of 36, or 6. Okay, well, we have time to do the last one. This time the x squared and the x term are already next to each other, so we'll just write x squared plus 10x, but I'll leave space for the completing the square part, and then write plus y squared minus 8y, and leave some space. This time we're going to add 40 to both sides, because we want the non-variable parts to be on the right-hand side to start with. Okay, then in the next step, we'll complete the square twice, once for x squared plus 10x, and the other time for y squared minus 8y. Okay, so to complete the square here, 1/2 of 10 is 5, 5 squared is 25, so we add 25 to both sides. And then y squared minus 8y, 1/2 of negative 8 is negative 4, and when you square negative 4, you get positive 16, so we add 16. And then the next step is the standard equation, x squared plus 10x plus 25, that's equal to the binomial x plus 5 squared. Y squared minus 8y plus 16, that's equal to the binomial y minus 4 squared. And then 40 plus 25 plus 16 is 81. So now we know the center. The center is -5 for x and +4 for y. And the radius is the positive square root of 81, which is +9. Okay, we got through all of the section 11.1 material today, so we'll be able to review for test 4 tomorrow, Wednesday, and Thursday, and then test 4 is on Friday. So that's all for today. We'll start in 1 minute. Today we'll cover the last section that we're going to cover this semester, section 11.1 on the distance formula and equations of circles. Remember that on Friday of this week we have test 4, which will be over the chapter 9 and chapter 11 material. To start section 11.1, we'll review the Pythagorean Theorem. The Pythagorean Theorem applies to any right triangle the longest side of a right triangle is the side opposite of the right angle. It's called the hypotenuse. So if we label the length of the hypotenuse C and the lengths of the legs A and B, then the Pythagorean theorem says if you square the length of the hypotenuse, that's equal to the sum of the squares of the lengths of the two legs. The Pythagorean theorem can be used to derive the distance formula, and it can also be used to derive the standard equation of a circle. First, we'll start with distance. So in this example, it says find the distance between the points 1, 2, and 5, 4 in the xy plane by using the Pythagorean theorem. Okay, so we'll sketch the xy coordinate plane. And then we'll plot those 2 points. Okay, so the ordered pair 1, 2 is right there about 1, 2. And the ordered pair of 5, 4 is about right here. And we want to find the distance between those 2 points. Well, we can construct a right triangle, and if we connect those 2 points with a straight line segment, then this will be the hypotenuse of the right triangle, and then the horizontal side we'll move to the right until we're directly below the other point. And then the vertical side is the vertical line segment that we connect with this horizontal line segment. And the horizontal line segment and the vertical line segment form a right angle at the point of intersection. Okay, so we want to find the distance between the ordered pair 1, 2 and the ordered pair 5, 4. But the distance is just the length of that hypotenuse. So I'm going to label the hypotenuse D for distance between the 2 points. And then we can easily determine what the length of the horizontal and vertical sides are. But I want to point out something that we'll use more generally. The x-coordinate of this point, which is the vertex of the right angle, is 5. and the y-coordinate of that point is 2. Okay, so the length of this horizontal side of the right triangle, you can tell just by counting the units. It's just 1, 2, 3, 4. But I want you to get into the habit of thinking of this as the absolute value of the difference of the x coordinates. So the x coordinate of this point is 5, the x coordinate of that one is 1. And so the distance or the length of that horizontal side is the absolute value of the difference of the x coordinates. And then we can acknowledge that the absolute value of 5 minus 1 is 4. And then similarly, the vertical line segment, you can tell by looking that it's just 2 units. But using the y-coordinates of the 2 points, the length of that vertical line segment is the absolute value of 4 minus 2, which is 2. Okay, then we apply the Pythagorean theorem to this right triangle. So we square the length of the hypotenuse, d squared, and that's equal to 4 squared plus 2 squared. And then we do the arithmetic. 4 squared is 16, 2 squared is 4, 16 plus 4 is 20. And then the distance is the positive square root of 20. And we want to simplify square roots whenever possible. So the positive square root of 20 simplifies to positive 2 times the square root of 5. Make sure that you can convert something like this to a decimal number if you are called upon to do so. Okay, using the same idea, we're going to derive the distance formula to find the distance between any 2 points in the xy plane. And those 2 points will be represented by x1, y1, and x2, y2. Okay, so we'll use a diagram again. So one of the points I'll label as x1, y1, and the other point I'll label x2, y2. So these are 2 points in the xy plane. We want to find the distance between those 2 points. So we can construct a right triangle. The hypotenuse will be the straight line segment that connects those 2 points. And then we connect horizontal and vertical line segments that intersect along the same vertical line that contains this upper point and the horizontal line that connects the other point. So those intersect and form a right angle. Okay, the x and y coordinates of the vertex of this right angle. See, the x coordinate of this point is x2, and the y coordinate of that point is y1. Okay, so we'll label the hypotenuse d to represent the distance between x1, y1 and x2, y2. But the horizontal side of this right triangle is the absolute value of the difference in the x coordinates. So here I'll just write the absolute value of x2 minus x1. And the vertical side of the right triangle, its length is the absolute value of y2 minus y1. Okay, then we apply the Pythagorean theorem to this right triangle. So we square the hypotenuse, d squared, and that's equal to the sum of the squares of the lengths of the 2 legs. Okay, so first we're going to square the absolute value of x2 minus x1. Since we're squaring it, we don't need the absolute value symbols anymore, because when you square a positive number, you get a positive number, and when you square a negative number, you get a positive number. So we'll just put x2 minus x1 in parentheses and square that quantity, and then we're going to add that to the quantity y2 minus y1 squared. And the distance is the positive square root of the right-hand side. So the distance between x1, y1 and x2, y2 is the positive square root of x2 minus x1 squared plus y2 minus y1 squared. This is called the distance formula, and it's derived by applying the Pythagorean theorem to a right triangle. Okay, it's probably not a bad idea to memorize the distance formula, but make sure that you memorize it perfectly. If you just make one little mistake, then that throws everything off. Okay, we'll do some examples where we apply the distance formula. Okay, so one of the pitfalls is the arithmetic. So be careful with the arithmetic. It doesn't matter which of the 2 points you label x1, y1. So you can do it either way. So on this one, I'll just point out what you can do. We want to find the distance between the ordered pairs 3, 2 and 7, 5. So it's the square root of something. So first focus on the x-coordinates. The x-coordinate of this point is 3. The x-coordinate of the other point is 7. And so the difference, I can write it as the quantity 7 minus 3 and then square it. And then we're going to add the square of the difference in the y-coordinates. Okay, the y-coordinate of this point is 2. The y-coordinate of the other point is 5. So I can write the quantity 5 minus 2 squared. That's one option. Okay, then we'll just do the arithmetic. 7 minus 3 is 4, and then so we have 4 squared, and then plus 3 squared, since 5 minus 2 is 3. 4 squared is 16. 3 squared is 9. And so we get the distance is the positive square root of 25, which is 5. Okay, this is more detail than you have to write, but by all means, if you need to write more detail, then do so. Okay, in the next example, we have an ordered pair 6, negative 1, and another ordered pair negative 2, negative 8. Find the distance between those 2 points. Okay, so the distance is equal to the positive square root of a number. So first focus on the x-coordinates. The x-coordinate of this one is positive 6. The x-coordinate of the other point is negative 2. So what I'm going to do, I'm going to write the quantity 6 minus negative 2 squared, and then plus, now we focus on the y-coordinates. The y-coordinate of this point is negative 1. The y-coordinate of that point is negative 8. So the quantity negative 1 minus negative 8 squared. So see what I mean about the arithmetic. You have to be careful with it. Okay, inside this set of parentheses, 6 minus negative 2 is the same as 6 plus 2. So 6 plus 2 is 8, so we get 8 squared. And then over here, negative 1 minus negative 8, that's equivalent to negative 1 plus 8. And negative 1 plus 8 is 7, so we get 7 squared. So the distance is equal to the square root of 64 plus 49. And 64 plus 49 is 113. The square root of 113 cannot be simplified further, but be able to convert that to a decimal and round it to either one place or two places or more, whatever the directions might say. Okay, a couple more examples. Find the distance between the point negative 7, negative 2, and the point 4, 6. Okay, so the distance equals square root of a number. So first focus on the x coordinates, negative 7 and 4. So we're going to all square the quantity negative 7 minus 4. And then we add that to, okay, so the y coordinates are negative 2 and 6. So negative 2 minus 6 squared. Then the arithmetic. So here, negative 7 minus 4 is negative 11. So I get negative 11 squared. And in the other set of parentheses, negative 2 minus 8 is negative 8. So I have negative 8 squared. When we square negative 11, we get positive 121. And when we square negative 8, we get positive 64. So we get the distance equals the positive square root of 185. So yeah, this won't simplify further because 185 is just 5 times 37. So this is the simplified square root. Okay, one more example. Find the distance between the points negative 9, 4 and 5, negative 3. Okay, the distance is the positive square root of a number. So first focus on the x coordinates, negative 9 and 5. So inside the square root and inside parentheses, we have negative 9 minus 5, quantity squared, and then plus, okay, the y coordinates are 4 and negative 3. So inside parentheses, 4 minus negative 3, quantity squared. Negative 9 minus 5 is negative 14. So we have the number negative 14 squared. And then in the other set of parentheses, 4 minus negative 3 is the same as 4 plus 3, or 7. So 7 squared. Squaring negative 14 gives us positive 196, and squaring 7 gives us positive 49. So then we have the distance equals the positive square root of 245. The square root of 245 can be simplified. 5 will go into 245 49 times, and 49 is a perfect square. So we can rewrite the square root of 245 as the square root of 49 times the square root of 5. And then the square root of 49 is 7. So the distance is 7 times the square root of 5. Okay, it's really not that hard to apply the distance formula, but as I keep mentioning, the arithmetic involving negative numbers, it's easy to make a mistake if you're not careful. Okay, now we'll start talking about circles. Well, a circle is, underneath it all, it's similar to what goes on with the distance formula, because one way to describe a circle is that it's the set of points that all have the same distance to the center. Okay, so what we're going to do in this first example, we'll draw a circle in the xy plane centered at 3, 4 with radius 2. And then we'll find an equation for that circle by using the Pythagorean theorem. Okay, so first, I'll draw a circle in the xy plane. Okay, so the center of the circle is the ordered pair 3, 4. The center itself is not part of the circle, but it's still an important point to know about. And then the radius is 2, so along a horizontal line, I can find a couple of points that are on the circle. So if I move 2 units to the right from the center, I get this point, which has coordinates 5, 4. And then from the center, if I move to the left 2 points, I have another point on the circle. This one is 1, 4. From the center, if I move vertically up 2 units, because the radius is 2, I get this point. This point is on the circle, so its coordinates are 3, 6. And then if I move downward 2 units to 3, 2, that's another point on the circle. And then the hard part is drawing a circle. So just pretend like my drawing is a circle. So you get the idea anyway. Okay, it says find an equation for that circle using the Pythagorean theorem. Well, I'm going to draw a bigger circle for that part so that we can see a little bit better what's going on. So the center is the ordered pair 3, 4. The center of the circle is always the same point, but a point on the circle can vary depending upon where you are on the circle. So I'm just going to pick this point, and since a point on the circle varies, I'm going to label this point with the coordinates x, y. Okay, then I'm going to construct a right triangle. The hypotenuse is the line segment that connects the center to any point on the circle. And the radius of the circle is 2, so the length of that line segment is 2. Okay, then we're going to finish constructing a right triangle by connecting horizontal and vertical line segments that intersect at a single point and form a right angle. Okay, so the length of this side of the triangle, it's the horizontal side. So if we consider the x coordinates, x and 3, well, that horizontal side, the length of it can be represented by the absolute value of x minus 3. And then the vertical side of that right triangle, so this time we consider the y coordinates, y and 4. So the vertical side, the length of that vertical side is the absolute value of y minus 4. Okay, so now what we're going to do, we're going to apply the Pythagorean theorem to this right triangle, except this time, instead of the hypotenuse squared on the left-hand side, I'm going to put the hypotenuse squared on the right-hand side. And on the left-hand side, I'm going to square the quantity x minus 3. I'm going to add that to the square of the quantity y minus 4. And then on the right-hand side, 2 squared is 4. Okay, so this equation is the standard equation of this circle. So the full statement should be the standard, or this equation is the standard equation of the circle whose center is 3, 4, and whose radius is 2. But it will be easier to remember what the standard equation of a circle is if you remember that this equation is just the application of the Pythagorean theorem to a right triangle. So this is like the length of one leg squared plus the length of the other leg squared equals the radius squared. It's just the Pythagorean theorem. Okay, so in the next example, we'll do the general case. We'll derive the standard equation of a circle whose center is the ordered pair HK and whose radius is R. Okay, so to do this, we'll just mimic what we did above in that example. Okay, so I'll draw a circle. This is supposed to be a circle in the XY plane. The center is the ordered pair HK. The X coordinate is H, the Y coordinate is K. And then I'll pick a point on the circle and label that point XY. And the radius of the circle is R. So when I construct the right triangle, I can label the radius, which is the length of the hypotenuse, as R. And then we construct horizontal and vertical line segments that intersect at a point. The horizontal side of this right triangle is the absolute value of the difference in the x coordinates of this point on the circle and the center. So it's the absolute value of x minus h. And the vertical side of this right triangle is the absolute value of the difference of the y coordinates of the point xy and the center. So this is the absolute value of y minus k. Then we apply the Pythagorean theorem to this right triangle. So we can write in parentheses x minus h quantity squared plus the quantity y minus k squared equals r squared. Okay, this is the standard equation of the circle, the standard equation of the circle whose center is the ordered pair HK and whose radius is R. So R is the positive square root of R squared. Okay, we'll look at some examples. We'll be given the information about where the center is and what the radius is, and then we'll just write down the standard equation for that circle and then sketch a graph of each circle. Okay, so the exercises say, given the center and radius, write the standard equation of each circle and then graph each circle. Well, if you know the center and the radius, then writing the standard equation is pretty simple. The x-coordinate is 1, so x minus 1 quantity squared plus the y-coordinate of the center is 3, so the quantity y minus 3 squared. And the right-hand side is the radius squared. If the radius is 2, 2 squared is 4. So that's the answer. That's the standard equation of the circle centered at 1, 3 with radius 2. Okay, then the tedious task is to sketch a graph of that. Okay, so the center is 1, 3. The radius is 2, so from the center, if I move up to 1, 5, so this point is on the circle. If I move vertically down to this point is 1, 1, that's a point on the circle. From the center, if I move to the right 2 units, this point is 3, 3. And then from the center, if I move to the left 2 points, this point is negative 1, 3. And then connect the points on the circle. Try to graph a circle. So that's, you get the idea. Okay, in the next example, this time the center is 4, negative 2, and the radius is 3. Okay, so the standard equation for the circle, we start by writing x minus 4 quantity squared plus y minus negative 2 quantity squared equals 3 squared. X minus 4 quantity squared is already as simplified as it can be. And then y minus negative 2 is equivalent to y plus 2. So we square that quantity. And then 3 squared is 9. Okay, so this is the standard equation of the circle centered at 4, negative 2 with radius 3. Okay, so we'll go ahead and graph this. The center is 4, -2, and the radius is 3. Okay, so from the center, if I move up 3 units, here I'm at 4, 1. And if I move vertically down 3 units, this point is 4, -5. Okay, the center is 4, -2. And then from the center, if I move to the left 3 units, this point is 1, -2. And from the center, if I move to the right 3 units, this point is at 7, -2. And then draw a circle. Or thereabouts, anyway. Okay, one more example of this. This one, the center is 0, 5, and the radius is 4. Okay, so first write the standard equation. The x-coordinate is 0, so x minus 0 quantity squared plus y minus 5 quantity squared equals the radius squared. X minus 0 is just x, so we get x squared, and then plus y minus 5 squared equals 16. Okay, so we'll sketch a graph of this. The center is 0, 5. 0, 5. The radius is 4, so if I move down 4 units, this point is 0, 1. If I move up 4 units, this point is 0, 9. From the center, if I move to the right 4 units, this point is 4, 5. And if I, from the center, move to the left 4 units, this point is -4, 5. And then we can connect the dots on the circle. So it sort of looks like a circle. You get the idea. Okay, now we'll do something that's a little bit more challenging. But the nice thing about it is that you know about, or you've practiced the tools for what we're going to do next before. This says write the equations of the circles in standard form and then find the center and radius. Well, you will encounter equations of circles that are not in standard form. And the task will be to write it in standard form so that you can identify easily what the center and the radius are. Okay, let me go back a couple of pages. When we derived the standard equation of a circle, remember it was just an application of the Pythagorean theorem. But in this standard equation, we have a binomial x minus h squared, and we have another binomial y minus k squared. Remember what you get when you square a binomial? The answer is a perfect square trinomial. So that is what is behind writing an equation of a circle that's not in standard form into standard form. It involves creating perfect square trinomials, or another way to describe it is that it involves completing the square. Okay, so back to this. In part A, x squared plus y squared plus 12x plus 2y equals negative 12. This is an equation of a circle, and we're going to get it into standard form. And in this one, we're going to have to create two perfect square trinomials, or we could also say we're going to complete the square twice. So the first thing we want to do, we want to rearrange the terms so that the x squared term is next to the x term. So we can rewrite this to look like x squared plus 12x. And then I'm going to leave some space. The reason is we're going to complete the square, so I'm going to leave space before I write plus y squared plus 2y. Leave some space before I write the equal sign, equals negative 12. Okay, then in the next step, we're going to complete the square on x squared plus 12x. We're also going to complete the square on y squared plus 2y. So first, x squared plus 12x. So keep in mind that whenever you complete the square using this method, you have to make sure that the coefficient of x squared is 1. We already have that, but if you don't do that in a different setting, then you'll end up in trouble. So the coefficient of x squared is 1. Then to complete the square, we take 1/2 of 12 and square it. 1/2 of 12 is 6. 6 squared is 36. So we're going to add 36 to both sides of the equation. The regular rules of algebra apply. Whatever you add to one side of the equation, you must add to the other side. Okay, then we're going to complete the square on y squared plus 2y. The coefficient of y squared is 1, so we take 1/2 of the coefficient of y and square it. 1/2 of 2 is 1, 1 squared is 1, so we're going to add 1 to both sides of the equation. And the next equation will be the standard equation. X squared plus 12x plus 36 is the binomial x plus 6 squared. And we add that to y plus 1 squared, because when you factor y squared plus 2y plus 1, you get y plus 1 squared. And then on the right-hand side, negative 12 plus 36 plus 1, that simplifies to 25. Okay, now we have the equation of the circle in standard form. And we can tell by looking what the center is. The x-coordinate of the center is negative 6. The y-coordinate is negative 1. And the radius is the positive square root of 25, which is 5. Okay, and the next one we'll do the same sort of thing. We're starting out with an equation of a circle it's not in standard form. Okay, we'll rearrange the terms. So we'll put the x squared followed by minus 4x. We'll leave space for the completing the square part before we write plus y squared minus 6y. Leave some space before you write the equal sign, equals 23. Okay, now we're going to complete the square for x squared minus 4x, and then we'll complete the square for y squared minus 6y. And then afterwards, we'll be able to write the standard equation of the circle and identify the center and the radius. Okay, for x squared minus 4x, since the coefficient of x squared is 1, we take 1/2 of the coefficient of x and square it. 1/2 of negative 4 is negative 2. When you square negative 2, you get positive 4. So we add 4 to both sides. Then for y squared minus 6y, the coefficient of y squared is 1. So that means we take 1/2 of negative 6 and square it. 1/2 of negative 6 is negative 3. When you square negative 3, you get positive 9. So we add 9 to both sides. Okay, the next step is the standard equation. X squared minus 4x plus 4 is the binomial x minus 2 squared. And then we add that to the binomial that we square to get y squared minus 6y plus 9, which is plus y minus 3 squared. And then 23 plus 4 plus 9 is 36. Okay, so the center is the ordered pair 2 for x and 3 for y. And the radius is the positive square root of 36, which is 6. Okay, one more example. Here's another equation of a circle. This time we don't have to rearrange the variable terms, x squared plus 10x and y squared minus 8y, but we do have to add the constant, add 40 to both sides. So we'll do that in the first step. X squared plus 10x, leave space for the completing the square, and then plus y squared minus 8y. Leave some space, write the equal sign, and then put 40, add 40 to both sides so that 40 is on the right-hand side. Okay, so now we'll complete the square twice, once for x squared plus 10x, once for y squared minus 8y. Okay, we have x squared plus 10x. 1/2 of 10 is 5. 5 squared is 25. So we add 25 to both sides. Then on the other part, y squared minus 8y, 1/2 of negative 8 is negative 4. When you square negative 4, you get positive 16. So we add 16 to both sides. And then the next step is the standard equation. X squared plus 10x plus 25 is equivalent to squaring the binomial x plus 5, and then plus y squared minus 8y plus 16, that's equivalent to y minus 4 squared. And then on the right-hand side, 40 plus 25 plus 16 is 81. So the center of the circle has an x-coordinate of negative 5, a y-coordinate of positive 4, and the radius is the positive square root of 81, which is 9. Okay, I'll do one example of something a little different. It's the same but different. So on this one, suppose you have x squared minus 5x plus y squared plus 3y equals 7. This is also an equation of a circle, but this time we have to use fractions. Could happen. So when we complete the square on x squared minus 5x, we take half of negative 5. Half of negative 5 is negative 5 halves. Then you square negative 5 halves, and you get positive 25 fourths. So we have to add 25 fourths to both sides. And then when we complete the square on y squared plus 3y, half of 3 is 3 halves. When you square 3 halves, you get 9 fourths. So we add 9 fourths to both sides. And then we can write the standard equation, x minus 5 halves squared plus y plus 3 halves squared. And 7 over 1 is the same as 28 over 4. And 28 over 4 plus 25 over 4 is 53 over 4. And then 53 over 4 plus 9 over 4 is 62 over 4. So the center is 5 halves for x, negative 3 halves for y, and the radius, when you take the positive square root of this, you get the positive square root of 62 in the numerator and 2 in the denominator. Okay, that's all for today. Tomorrow and Wednesday, we will review for test 4.